Many creative and future initiatives in the military technology and development business have been shelved in favor of some other city. The American YF-23 suffered a similar fate after being rejected by the United States Air Force. Japan took over the project's development and is presently working to bring the YF-23 back to life. The YF-23 was a 6th-generation fighter in a 4th-generation world, and it was so far ahead of its time that the United States didn't know if it needed a powerful weapon, so they locked it up and canceled its program. On the other hand, Russia and China had the most reason to rejoice, because if the YF-23 came to fruition, their quest for domination would become much more manageable. However, with Japan willing to cooperate with a foreign business to produce their top-of-the-line fighter, the YF-23 could be resurrected, reintroducing the world to possibly the most advanced fighter ever. Northrop Grumman designed the YF-23 in the final years of the Cold War, and it featured a greater range and significantly better stealth characteristics than the F-22, as well as a similar weapons load. The F-22 was more survivable in visual range battles, but its ability to operate as a carrier-based fighter with a few easy conversions, as well as its cheaper unitary cost, were major reasons for its selection. The U.S. Air Force's budget was becoming increasingly stretched when the Cold War ended, and the successor states of the USSR appeared unable to compete with the latest American fighter. As a result, the lower-priced, slightly less capable fighter was favored over the higher-end F-23, saving the Navy the cost of developing an altogether new carrier-based platform. In the Advanced Tactical Fighter program, the YF-23A competed against the YF-22A in the late 1980s and early 1990s. The U.S. Air Force needed to replace the F-15 Eagle air supremacy fighter in the late 1970s due to a new generation of Soviet aircraft and surface-to-air missiles. The U.S. Air Force granted demonstration contracts to two industry teams in 1986, Lockheed Boeing General Dynamics YF-22A and Northrop McDonnell Douglas YF-23A. The Northrop YF-23A, often known as the Black Widow II, was designed with stealth. Northrop decided against utilizing thrust vectoring for aerodynamic control, which was used on the Lockheed YF-22A, to save weight and improve stealth. Northrop manufactured two YF-23A prototypes. The Pentagon was looking for next-generation aircraft to compete with the Soviet Union's Su-27 and MiG-29 fighter prototypes, which had been seen by spy satellites in the late 1970s. Survivability, supercruise long supersonic flight without afterburners, stealth, and ease of maintenance were all criteria for the U.S. Air Force's Advanced Tactical Fighter. In 1990, the YF-23 and YF-22 fought head-to-head after nearly a decade of development. Secretary of the Air Force Donald Rice announced in April 1991 that the YF-22 had won the competition. With the Cold War over and the threat of Soviet fighter development reduced, the fact that it was more agile than the YF-23 was the deciding factor. Engineers who worked on the YF-23, who were able to talk about the project after it was declassified, believed their aircraft was the better option. And given the F-22 Raptor's current problems, their arguments appear valid. What is the difference between YF-23 and F-22? Both the YF-23 and the F-22 were developed during the Cold War. The U.S. considered its Air Force to be ineffective. Against the former Soviet Union, NATO, commanded by it, lacked formidable fighters. As a result, the Pentagon requested that a low-observation fighter be developed. It's a stealth fighter that's well known. YF-23 fighter jets clashed strongly with F-22 fighter jets in the model campaign. After defeating the YF-23 stealth aircraft, the F-22 became the world's first mass-produced fifth-generation stealth fighter. The YF-23 is one of the more distinctively designed planes. It had diamond-shaped wings and a V-tail, giving it an unusual aspect. It was practically undetectable due to its fantastic climbing, vertical speed, and stealth qualities. The YF-23 has proven to be a reliable aircraft, thanks to its thrust vectoring engines and fly-by-wire control system. It featured the supercruise function, which was a new concept for attaining prolonged supersonic flying without the use of a fuel-hungry afterburner or any other sort of specialist engine augmentation at the time. The YF-23 was able to achieve incredible straight-line speeds while yet maintaining stealth. The YF-23's low profile and classified skin material made it even more stealthy. Most radar systems of the time would be unable to detect this next-generation aircraft, according to reports. Only 2 YF-23s were built, and the first flight occurred on August 27, 1990. The wingspan was 13.3 meters, the height was 4.3 meters, and the wing area was 88 square meters. The length was 20.6 meters, the wingspan was 13.3 meters, and the size was 4.3 meters. The weight is 13 tons in no-load mode. The maximum takeoff weight is 29 tons with a full load. It can fly at an altitude of 19,800 meters and has a top speed of Mach 2.2 and a cruising speed of Mach 1.6. The fighting radius is 1,380 to 1,480 kilometers, and the thrust-to-weight ratio is 1.96. It has completed 50 test flights, totaling 6 to 5 hours of flight time. On the other hand, the F-22 fighter jet ranked second and America's first mass-produced fifth-generation fighter jet with the shortest production cycle, have now been retired, leaving the U.S. with just heavy fighters. The wingspan is 13.56 meters, the height is 5.08 meters, and the wing area is 78.04 square meters. The weight of the aircraft exceeds 19 tons when empty, 29 tons when fully loaded, and 38 tons when fully loaded. It has a maximum flight speed of Mach 2.25 and a cruising speed of Mach 1.82 and can battle at a height of 20,000 meters. Furthermore, it has a maximum range of 3,000 to 3,220 kilometers, an 851-kilometer fighting radius, and a thrust-to-weight ratio of 1.08. Although there isn't much size difference between the two, the YF-23 is lighter and performs better in terms of endurance and battle radius. Although the YF-23 lacks vector nozzles, horizontal control surfaces, and afterburners, the fuselage structure is rather basic and has slightly more excellent controllability at low speeds. In general, each has its qualities, the performance difference is narrowed, and each has its advantages. The most fundamental reason for the YF-23's bid failure is that it is not as maneuverable as the 22F. So, why did Japan choose the YF-23 rather than the F-22? The reason is straightforward. At the Joint Chiefs of Staff meeting on September 27, 2006, the U.S. Congress reviewed the export prohibition on the F-22. The Department of Defense announced that it would not export this model shortly after. Despite the U.S. Secretary of Defense declaring in 2008 that he was not opposed to the export of this type, Congress must change the law. This legal amendment will be indefinite due to the United States bicameral constitution. As a result, the Japanese government's first choice is the YF-23, which has a minimal difference in performance. In general, the Japanese X-2 mine demonstrator is built with dual engines, vector nozzles, and dual vertical wings. The body shape incorporates an uneven surface and rounded ammo design, effectively reducing the cross-sectional area of radar reflection. The performance test phase for this aircraft finished on April 22, 2016, after it successfully flew for the first time. The F-3 fighter will be developed using this test airframe's research and development results. As previously stated, Japan's next-generation fighter F-3 inherits the YF-23's aerodynamic shape, which is substantially smaller in size and has comparable stealth performance to the F-22 fighter, which is no longer in production. Northrop and McDonnell Douglas, two American military aviation behemoths, collaborated on the YF-23. Northrop has done extensive research into stealth aircraft. This firm is proud of the B-2 stealth strategic bomber, which is well known to the general public. This fighter has improved performance and a price tag of up to $2.4 billion. As a result, one of the causes for the YF-23 campaign's failure is the fighter jet's financial overrun. The Japanese Ministry of Defense admires the company's stealth technology and the YF-23's technological knowledge will likely be revived in the F-3 project. It is entirely possible, based on the existing scenario. Japan's Ministry of Defense had already sent a request for information to international military aviation behemoths, such as the US and the UK. Why aren't the Chinese or the Russians copying the YF-23? They don't just design any stealth aircraft for a variety of reasons. Their criteria are vastly different from those of the United States Air Forces. Stealth continues to be a total waste of money. The YF-23 had a high supercruise speed than the YF-22, but the YF-22 had already demonstrated that it was several tenths of a Mach higher in supercruise speed than the specs. The same thing was confirmed with the radar cross-section of the two aircraft. In the design of a stealth aircraft, many different techniques must be used. Some surfaces need a material that absorbs only some of the RF energy. Other characters need not only an absorbent material on the outside, but also angled to help defeat the RF energy. Within the layers of materials of the F-35, there is also an embedded wire mesh. A voltage is given to the mesh to minimize the radar cross-section of the panel. These are only a few of the new advancements being made to minimize an aircraft's RCS, which lowers the plane's cost, maintenance costs, and RCS simultaneously. Could you believe Russia or China will invent new aircraft to compete with Japan's reborn YF-3? That is all for today's video. Thank you all for watching. Hope you guys enjoyed it. Don't forget to like and subscribe for more content like this.